Okay, advanced modeling and visualization. Today's topic, animation, but partially animation. At the end of today's lecture, that's animation. Today, in the lecture, I'm going to bring your attention again to review this course, okay? Digital design and visualization. So this is kind of the last minute review for taking the exam today, okay? And series of lab exercises, mental way, multi-pass and Costis effect, as well as series of animation making techniques, lab exercise. So at least 50 sequential JPEG images for the animation making and another 50 sequential JPEG Photoshop edited. I'll let you know what to do and some demonstration if we have time. Anyway, let's take a look again where we are. We are in 12th week, midterm exam today, okay? And next week, previewing BIM using Revit. So the lecture going to show you some BIM pragmatic application, how to use BIM applications, what is BIM technologies for real world projects. That's the topic for the lecture. And then some Revit previewing lab exercises, okay? And 2 more weeks for project progress report. For your final project, I like to see you one by one for reviewing what you have done for your final project. And also you need to bring your final project stops next step to next week and December 12, okay? And also I like to show you exam result and lab exercise result, whatever you need to see before the final. After that, we are going to have final project review, okay? You don't have some presentation, just reviewing your submissions at the end of the semester, okay? Anyway, before today's lecture, again, I like to bring your attention about the final project. First option, photorealistic render. Second option, architectural design image, which means anything for your design representation. But at least one photorealistic render and Photoshop retouch or something else, some post-processing. That's the requirement, okay? So usual reference websites, images I show you, and the URL, you can find out lots of things, but mostly they are architectural images, not photorealistic. Some of them photorealistic. You can find out what you need to do based upon your design studio project or your own individual project. Even if your design studio is not yet finished, you are still working on it, struggling what you are designing in the studio, it doesn't matter, okay? I like to see just best, effective, very nice, visually effective visualization, simply because the literal meaning of this class, digital design and visualization, okay? Your design material going to be finished in your studio course, but in this course, it doesn't matter, okay? Whether your design finished or not, try to find out best effective visualizations using the final, at least 2 images, okay? Okay, before reviewing the course, I like to show you this one again. There is a concept, high level versus lower level, and another concept, another comparison between high LOD, low LOD. LOD means level of detail, okay? So what is LOD? Simply, we experienced this one 2 weeks ago. Take a look. This is original file of Stanford Dragon, which has 100,000 polygons. Another one, 10,000 polygons. So this one, this original Stanford Dragon has 10 times more polygons, okay? So in terms of level of detail, which one is high LOD? Of course, this one, okay? This is higher level of detail, lower level of detail. In the same way, take a look. Let's think about you are designing this kind of tower. At the beginning of the project, you can think about its roughly measured height and roughly designed geometric shape in this way, okay? This is the lowest level of detail, okay? Low LOD. But in your progress, at the end, your final product has very fine-grained details in its surface, geometric shape, material, color, and so on, okay? So it's high LOD. Take a look at this face. High LOD simply means more polygons. Lower LODs, fewer polygons in terms of its geometry, okay? But actually we say high LOD to something well developed or highly advanced or highly developed, okay? At the beginning of the project or beginning of something, we usually say lower level of detail. So take a look, building life cycle, planning, designing, kind of lower LOD, okay? But if you dig into the design development, at the end of the design process, your design model has very, very detailed features for your real building design. That is highest level of detail. Even in construction phase, somebody needs even more fine-grained and really detailed geometric shape and information. That's even higher level of detail, okay? So let's think about the conceptual things regarding LOD as well as levels, high level, lower level. So in general, high level means introduction, outline, general theory. This is high level, okay? In other words, it's coarse detail, but it has a big picture, okay? But no details. How about low level? It has detail, particulars, specific theory. In other words, it's fine-grained. You know the coffee machine, okay? Grinders. Grinder, if you use grinder in fine-grained mode, your coffee output going to be really fine-grained coffee, and then you can get some very kind of thick or something coffee. But if you put it in something coarse-grained, which means granularity, each particle is bigger than fine grain. So this is the meaning of coarse grain, fine grain, okay? Let's think about comparison between level of detail. What's the level of detail we pursued in the class? I'm talking about digital design and visualization course, this course. In general, design computing course, okay? In high level, developing the capability of design computing, your capability of design computing, digital design, enhancing your digital communication skills, practicing digital design presentation, something big, okay, something broad. That is high level, okay? How about this one? Training precision drawing tools such as AutoCAD, SketchUp, 3D rendering, visualizations, Photoshop. They are low level, okay? So let's talk about the level of detail. Which one is higher level of detail? Low level, okay? In low level, level of detail is getting higher simply because now we are dealing with some specific tools, specific software, specific details, okay? But in high level, in other words, in lower level of detail, we are dealing with something outline, general things, theory, introduction. We are undertaking in this semester entire part from high level to lower level. Theory course, lecture series, and lab exercises. Even lab exercises has some different levels. Anyway, these are some conceptual things you need to know in terms of high-low level and high-low level of detail. Let's get reviewed some 3D modeling and design visualization issues, exactly what we have walked through, what we have learned. Let me quickly introduce you and show you what we are dealing with, okay, in the course. As I showed you before, there is very famous one single slide history, okay? Review CAD history. The first one is the design is a drawing of the product. For example, geometric drafting in 2D. The second stage, the design is a surface model of the product. Third, solid model. Fourth one, parametric model. The last one is building information model. So where we are, as I introduced you before, we are in the second stage. Okay. You have learned digital design and some design computing related course in our department since when you were freshmen. Okay, since last year. So 2 years. We spent 2 years for those two parts. In a metaphor, I can say this is elementary school, this is middle school level, high school, undergraduate, and graduate school level. So in terms of CAD history, we are still in middle school level, okay? 3D Max, SketchUp, Rhino, Maya. Our general 3D geometric tools are all in this category, which means middle school level in terms of its CAD history. So how about next phase things, next semester? That's what I told you before, okay? Solid model, parametric model, BIM models, they are all usually integrated. And the BIM tool, such as ArchiCAD, Revit, they have all those features, okay? All the features it has. So this is the most advanced one. But we are in still this stage. Why we are still in this stage? As I told you before, surface model, lightweight, handy, very, very good to visualize anything. Take a look this one. In real world, there is no this kind of object. This one has entire surface, zero thickness. But in real world, this one is supposed to be 0.1 millimeter thickness by real product, real material. Anyway, this kind of mathematical definition can be represented by computers virtually. So this is the simple manipulation of surface control, exactly same you control surface in 3D Max, even in Rhino or SketchUp, whatever. But this is not real, okay? Games use surface model 3D, surface-based 3D, simply because this is lightweight, okay? Not heavy loaded, very fast. And this one can visualize anything you can imagine, okay? But how about this one? Solid model. This is real world object, unambiguous computer representation, which means exactly same mechanism to real world object. So those are non-solid surfaces, dangled single surface, a line. In real world, there is no line, okay? No line object. Klein's butter is, this one doesn't have inside, outside, okay? 3D version of Möbius string, that's what I told you. So those are invalid, ill-defined 3D. How about devil's fork? This is ill-defined, okay? It's invalid, it's a fake. This one cannot be made in solid model or in real world. How about this one? Ambiguous. Okay, this one can be this one or anything else here. So why we need a solid model? Solid model knows if you put a point, it can detect whether this point is outside of this product object or inside of the product. Okay, solid model knows inside and outside, simply because inside is mathematically defined as a solid part. Okay, so Boolean operation, cut, inset, extrusion, plus, minus, union, intersection, all the operations are available, no problem. Okay. Anyway, this is real-world product representation method implemented in computers, solid model. Okay. We need to take a look the comparison between geometry and topology quickly. Why? We need to know some fundamental basics in computer graphics. Okay. So this is geometry and topology in Korean, 위상. Okay. Why we need both of them? Take a look this one. How to define this rectangle shape by computers. Computers understand mathematic, well-defined, precise definition. So take a look at this process. 4 points in XY Cartesian coordinate system. Okay, 4 points and their connections. And let computers or this system know this is the surface enclosed. Okay, and then computer can visualize that rectangle shape based upon this mathematical definition process. So let's take a look at this one, topology. This is geometry, okay, which has coordinate points. How about topology? Take a look, this connection. Topology defines the relationship between vertices and edges at the end face. Let's take a look at the comparison, topology versus geometry. The first thing is same topology. Let's take a look. I told you topology defines the relationship. Starting point, vertex 0, end point, vertex 0. How about second one? Starting point, end point, same, okay, vertex 0. But they are looking totally different, which means different geometric shape, okay? They are geometrically different, but topologically same. How about this one? Same geometry in terms of the location of the points, okay? 4 points in the same location, but different relation. In other words, different topology makes totally different output. Take a look, rectangle shape and the cross. So what we need? Geometry, topology. Both geometry and topology are necessary, okay? Geometry defines values of points, location of points. Topology defines relations between points. Let's take a look some terminologies. On the geometry, point, line, surface, space. On the topology, vertex, edge, face, shell. Those terms are in 3D Max, editable poly. You are very familiar with those terms, okay? So you can control vertex, edge, face in order to control the final geometry, okay? Problems of unclosed surface. Let's take a look, those 3 geometric shape. When you extrude using this section profile, number 1, 2, 3. Okay, obviously those 2 are 3D and they are surface-based 3D, obviously. They are not solid-based 3D, okay? Because this one doesn't have thickness. How about this one? Of course, this is surface-based 3D, but there is a possibility this one can be defined as a solid 3D, okay? In other words, this one can be both solid 3D and surface 3D, but this one only can be a surface 3D. This is not a solid 3D, okay? So we need to define well-defined section profile, enclosed one. So starting vertex, ending vertex supposed to be exactly same, and then we can make this topology enclosed, and then we can make valid 3D. You remember what we have done when we import CAD file? Take a look this one. Yellow point means starting or ending point, but too many, ill-defined. Why? This one is given geometry. 3D Max doesn't know what is this. So we clean up this line, okay? We clean up that CAD file using weld function, and then take a look this one. This one single shape has one single starting and end point in yellow. So we can make this kind of solid looking 3D geometry without any hollow inside wall, okay? That's exactly what we have used in lab exercise hours, okay? So this is the difference between solid and surface-based 3D definition. Even if this is surface-based 3D modeler, 3D Max, it doesn't matter. 3D Max anyway knows whether it's valid definition in 3D or unclosed section profile for 3D extrusion or something. Okay, let's quickly move on. Geometric modeling versus information modeling. Information modeling is the most advanced direction we are now exploring. Anyway, information modeling for building, simply say we are calling it BIM, because information modeling plus building, that's building information modeling, okay? Information modeling contains anything of geometric modeling. In other words, geometry is one part of information, okay? So let's take a look at this one. From 2D drafting to 3D modeling, this is conventional drawings, floor plan, elevation, section, 3D axonometric, and 3D surface model. I told you somebody developed this one, and solid model, but this is just 2D drafting. This is 3D model. Why we need 3D model? Capturing some visualizations from the model. So how to derive elevation, front view? Simply rotate this model in front view and then take the scene or render the scene, okay? What if you need floor plan? Cut the section and then make a top view. That's the floor plan, okay? So rendering, even animation making, all they are some part of this extraction from 3D model. We don't need to draw again, okay? All 2D drawings, draftings are subject to be extracted from 3D model. What's next? I told you, you know what is next? 2D drafting, surface model, solid model. You know what's next? Parametric model and building information model. That's the most advanced one. So why I show you this one? This one is looking iPad, tablet application or your smartphone app named HomeStyler. This one also has PC version. You can access homestyler.com and you can design in both 2D and 3D. The reason why I show you this one is simply this is BIM tool. Okay, this is not AutoCAD 2D drawer or SketchUp 3D Max like 3D surface-based modeler. This is building information modeling tool. take a look, this PC version. If you click one of the wall object, this home style, this is not an application. This is web browser. You can use Chrome, Explorer, Safari, whatever, and then you can open this application. This one is working inside of this web browser. So if you click this wall, home styler knows this is wall object, and then you can change wall style, wall opening, and finish the wall color, decoration, and so on. Take a look. This is 3D view of home styler design. This is 2D view, edit mode, and this is 2D edit mode. But if you change the 3D view, you can visualize in this way. You can extract from this home styler to Revit, okay? Not just the simple geometry. Also, you can the CAD file you can extract from this home styler, simply because this is BIM tool, the most advanced one. Even if it's looking web-based, small size application, it has really powerful features, okay? How about home styler mobile version? Mobile version of home styler also has building information modeling approach. It has auto detection of ceiling line, wall line, floor line. And this one can also support the editing function. Take a look. This is just a regular picture of the corridor, elevator hall. And by using this tool, you can change the color of this wall. Even you can load this furniture, even picture frame, and so on, okay? Change the floor material from this stone to the wood floor, okay? By using your smartphone. You can install home styler smartphone version on Android, iPhone, whatever. You can also load any given empty space in order to decorate something like this, okay? If you click one of the material, home styler knows whether this furniture is real world furniture or just geometry. It has price information and it has some material details and lots of associated information you need. Home styler, if you click this door object, take a look. Double entry door, cherry color. Simply home styler knows something about this door. You can extract geometry into DWG CAD file. But if you load that CAD file, the same model, okay, this simple design can be extracted to AutoCAD. And then you can click this object, door object. But the problem of AutoCAD is it doesn't know this is door. This AutoCAD only displays layer information, geometric position X, position Y, position Z, Cartesian coordinate system. That's it, only geometry. But if you load this one into Revit, take a look. If you click the same object, Revit knows this is double panel door object and associated properties, door properties, okay? So this is the main difference between BIM and geometry. In AutoCAD, everything in geometric data. In BIM tool, object-oriented definition and associated information. A lot more information you can append. So why this difference has been made? At the beginning of the CAD system, let's take a look at this picture. This is very famous picture, MIT Media Labs Sketchpad, the first CAD system in 1960s. At that time, we are focusing on geometric shapes. So we made something, let computers do what we have drawn. At the beginning of the CAD, without computers, what designers are doing, drawing, okay? Because we are believing drawing is design. So we just use computers for drawing. That's the earlier version of computer-aided design system. But we are smart. We invent new software, new approaches. At the end, we invented something, let computers do what we have done, okay, including entire process. We are focusing on information, not just geometric shapes, okay? That's the concept of building information modeling, and this is the most advanced features we have invented. So let's compare two same geometry. Take a look. Very simple rectangle shape room, okay? But in SketchUp, 3D Max, AutoCAD, there are 2 points and 2 rectangle shapes. That's it. But in BIM tool, 4 points, 4 walls, and 1 single space, okay? So its formal definition in this diagram also has very different representation. They are looking very same, okay? They are looking very close, but computationally very different. Totally different, okay? That's the point. That's the difference between those two approaches, geometric and information modeling. So what we need to know, what we have learned, you know editable poly, okay? Controlling vertex, edge, face, shell. For the box, we need to control vertex, edge, face, so-called editable poly mode, topology or geometric control. And we have learned this process and this process, okay? Geometric controlling modifiers in 3D Max, especially in 3D Max. Take a look. You know how to control light object, materials, camera viewing, and this kind of modifiers, editable poly edits, geometry centered, some parameters. What kind of parameters? Width of the box, height of the box, that's the parameters, okay? For editing, update vertex, edge, polygon, lots of geometric things you need to know and you need to control. How about this process, this one? Parametric modeling, building information modeling, such as Revit. For defining this one, you need to define the part component. This one can be used in your design, something like this. Next semester in the Revit family editing and some curtain system making, window making, family making, lab exercise, you're going to learn how to do this. Anyway, looking similar but totally different, okay? There is no overlapped geometry. They are all solid model. They are real-world object-like definitions. Object-oriented modeling and design. Update information is the way of modification, editing. Okay, how to represent your design? How to visualize your design? That's the question. Architectural design, construction, and representation. Let's take a look at this one. Vitruvian Man, drawn by Leonardo da Vinci. You know what is this image? It's something about human scale. Why it's Vitruvian Man? Referring to Vitruvius. 2,000 years ago, Vitruvius invented plans, elevations, sections, and some generally used standard, industry standard drawings for architecture design. Around 400 years ago, Leon Battista Alberti, also referring to Vitruvius, he suggested the separation, distinction between design and construction. Okay? What this mean by? This means before Alberti, design and construction all day integrated, okay? In the same way, someone in charge of building design, he also in charge of constructing that building, okay? That's a regular process. But after that, even modern architect, representatively Louis Sullivan, form follows function, in his book, also referring to Vitruvius. This is representative modernism phrase. That's why I put this note here. Even nowadays, we are living in modernism world, even if we have more design trends or something. My point here is using those industry standard 2,000 years, separation of design and construction, 400 years. At the beginning of the computer-aided design, beginning of the CAD, we just use only for drawing. But nowadays, the cutting-edge technology BIM is challenging integration of everything. Integration between design and construction, integrating all the regular representation, visualizations of design into information model, building information model, okay? So compared to human history, several thousands of human history, how long we have been using computers? Just 30 years, 40 years, okay? But that 40 years computers have changed almost everything. Especially just 10 years building information modeling is ground shaking, simply because this one is going to back to real world design approaches, integrated construction, considering constructability. Design supposed to be something like this. That kind of approach can be done, can be implemented in BIM approach, okay? Not just geometry-oriented technologies. We are designing building, we are designing chairs, furniture, but in real world, we are dealing with vertex, edges, faces, shell. They are not relevant to real world product, okay? We are dealing with material, price, color, budget, and the relationship between other objects and so on, okay? Intrinsic problems. So those things are something about geometric modelers, visualization purposes. Let's take a look at this one. Site has building, building has floors, floor has spaces. Spaces can be grouped by anything, interior facilities, finishings, furnitures, anything can be one part of space object. This is architectural fundamental approach when you are designing something, okay? How about structure? Amount of structural elements, even window, door, even opening. Opening is just nothing, hollow void space on wall object. But anyway, thanks to opening, we can place window or door object, okay? So entire things are all about structure. But this yellow part is exactly what we are designing, rooms, spaces, okay? We are not designing structure, beam, columns. We are designing spaces, and consequently, we need to control columns, ceiling, slab, or floor, material, and so on, okay? Our intrinsic main target is spatial object. What I mean is spatial, something about spaces, rooms, okay? Traditional communication in design. Here I list up simply the process of visualization. You have very unique design idea, but no one knows except your brain. So you need to make something abstract, okay? Abstraction. Something symbolized visualization from your head, or some oral presentation, or some languages, whatever, okay? Anyway, conventionally, we are drawing some bubble diagram sketch or 3D sketch, industry standard drawings, floor plan, section, elevation, and so on, axonometric, isometric, 3D. Very typical 2D plans. Take a look. 1893, there is a picture, drafting by hand. This is very old-fashioned architecture, architect firm, okay? They are using this kind of plate, drawing plate, and they are drawing by hand, long time, okay? So this is conventional way of visualization. In a conceptual, in a procedural mode, we can say design mode, okay? 3 very simplified design mode: mode of thought, mode of expression, and production. Of course, production is realization process, construction process. Mode of thought is invisible, okay? Something conceptual. Your conceptual representation part. How about mode of expression? This is very important thing when you are using your computers, digital tools, or even hand drawing. So, in mode of thought, design is a plan on abstraction which generates idea and concepts, your ideas, your concepts, okay? How about this one, mode of expression? Design is a way of visual equivalence, exploiting a medium's unique qualities to maximize meaning. Maximize your idea using medium's unique quality. Finally realized. How about a medium's unique quality? Exploiting. What is the meaning of this? You have to use maximum function, maximum capabilities of medium. What is your medium? In front of you, what is in front of you? Computers, okay? The medium is computer. That's the main subject in digital design and visualization course. Why digital design? We have learned lots of conventional representation, hand drawing or something, especially why 3D computer graphics? Why digital design? For enhancing your design visualization skills. Exactly why we are learning mental ray, V-ray, lighting, material, some texture mapping, bump mapping, and lots of more things in geometric modeling and rendering techniques. Another big reason is for moving forward to advanced design computing issues such as building information modeling. I told you next phase, next semester issue. But anyway, this is undergraduate and graduate level studies. We are working from elementary, middle, high level, high school level studies in sort of detail for enhancing your techniques, skills, okay? We have idea. We build computational model. Why? Simply because we need to represent our design. Digital design presentation, plan, 3D sketch, pictures, animation, anything from model. Without model, from your head to directly to your drawings, to your something, presentation material. Very iterative, time-consuming, laborious. But if you use one source means your well-defined computational model. Multi-use means lots of digital design representation, presentation, visualizations. If you plus more information about that building, that is so-called building information model, building information modeling, okay? What we have to learn are, I introduced you this one at the beginning of the semester, fundamentals of computer science and engineering theory, some basics. Computer hardware, you need to know computer hardware simply because we need to maximize the capability, functionality of your design medium. What is your design medium? computers. That's why you need to know some about hardware, network, internet. Nowadays, we are connected to online. I know you all know internet, web browsers, websites, social media, Facebook, but think about how much you know about network render, cloud-based render, or cloud-based design. You are very good at Facebook, but not good at such things exactly you need, okay? Facebook doesn't make you money, but something, if you are in design area, design domain, anyway, that's going to be kind of more of importance. Computer software, including Windows operating system, to save your time for efficiency. All data in gray font, which means something background behind the theory. But in black font, in the series of lectures, I taught you some fundamentals of design computing theories. In the lab exercise hours, computer software, specific applications focusing on 3D Max design, Mental Ray, V-Ray, Photoshop, and so on, okay? They are all the subject for design visualization. You know Maya or Rhino, SketchUp, it doesn't matter. All they are something about some exercising things. No one can teach you. You have to do by yourself. But actually there are more, even more things about design computing. Amount of more things. Actually I introduce you, some of you, something from this, something beyond CAD or something beyond digital design. I introduce you something before, but in next phase class or some other chances, I'm going to show you lots of more examples. Currently we are developing, okay? Okay, 3D visualization of design. The first one is still image. How to make a still image designed by hand. How long? For thousands of years. I believe almost the same to human history, okay? Even in very, very ancient cave, there is a wall painting, right? So design by hand using pencil is long-lasting design medium. But nowadays, design by computing. How long? I told you 30, 40 years. So thousands of human history, thousands of years, 30 years, 40 years. But these 30, 40 years, computers have changed everything. Design by pencil to design by computing. That's a major change we experienced. Pencil still is the most basic media of design. Even if we have computers, we use pencils, ball pens, and lots of some additional pens or some drawing media, okay, tools. Thanks to IT, information technology or hardware, smartphone, tablets, what's new media for design? Actually, nowadays, you have amount of design media, so-called digital design media, okay? Not just simple pencils. So we need to know about pencil because we need to use pencils. How about computers? We need to know computers because we are using computers. Very simple and very, very complicated because there are many design media, okay, compared to pencil. Visualization, you can download this geometry, put some lights, and just render to make this kind of photorealistic visualization. SketchUp plus V-Ray. How about this one? Download geometry and something visualized in this way, okay? Photorealistic visualizations and some technical representation method in this way. How about this one? Some professional made this kind of visualization, very realistic. Another example, let's take a look our department student example. When they were freshmen, they made those SketchUp model and V-Ray render and Photoshop edited final images. How about this one? GC Museum example and slipbox case. Even if something coarse and not that precisely defined, anyway, even freshmen can visualize this kind of design outputs, okay? In X-ray view mode, grayscale render, and so on, okay? It doesn't matter whether this is chair, real chair, or a digital chair, which means a fake, okay? I told you before, we are dealing with design computing, and design computing is eventually a design, not computing, okay? So, even if photorealistic rendering or architectural conceptual rendering, anything, it doesn't matter. Only design matters, okay? That's my point. This kind of photorealistic professionals rendering output in IKEA brochure, all they are digital, okay? For several reasons. Done by something like this guy. He used lots of digital tools, applications, environments, computing hardware, software. We have learned and walked through this kind of visualization skills and techniques in digital design and visualization class for making design, captured design, still image. But the animation is the next phase, today's lab exercise and this issue. Okay, let's have a break and move back to the lecture slide, okay? Okay, 3D visualization of design. As the course title, Digital Design and Visualization, we are struggling the visualization of design. The first one, as we reviewed, still image. We have learned photorealistic rendering and retouch, architectural visualization. How about animation? What is animation? Technically, same to still image, okay? But it's image sequence, okay? Series of images. In other words, many renderings, many renders, okay? And then you can make animation. Let's take a look at this example, video-based design presentation. Video-based representation of design. Exactly same to the flipbook animation, okay? Let me show you this example video. A student printed entire his render outputs in a single small pages and he clipped something like this book. And he gonna show you certain type of flipbook animation. Exactly explains you what is the animation, okay? The title is same, flipbook, okay? So he printed out his final representation result, something like this, and just simply flip the book. And then we can see by walking, okay? Something like this. Play it again. Print them out in his renders and make this visualization, okay? So why I show you this one? This is exactly same mechanism you can create in 3D Max animation, okay? Sequence of images, eventually gonna be animation, movies, okay? So you know how to render a scene, still image. If you know the sequence of renders, images, and then you can create certain type of video. So why video? Why video is so commonly used presentation material? Video-based design presentation, so-called multimedia, is easy to follow. That's the main reason, okay? you don't need to make very diverse kinds of visualizations, images, something beyond description. But as a picture is worth 1,000 words, the same way. Nowadays, you are very familiar with video, animation. Even in Facebook, Instagram, or any kind of websites provide you a bunch of video. Nowadays, we have very high-speed internet access and some better technical environment to show you high-quality videos, okay, animations. That's the reality, okay, in your daily life. But why don't we use this kind of design representation method? Nowadays, it's really easy and handy for making and presenting by using videos, simply because it's a sequence of images. Okay, this is my class website. On the My Class website, you can find out lots of your some senior students' final work. In next semester, in digital design course, your final project option going to be this one, okay? Video-based design presentation using your video authoring tools using lots of still images, render images, and 3D Max or SketchUp-based animations, clips you made, okay? These are examples. Let's take a look at the components of video-based presentation. Introduction, title, some text. Of course, they are some part of your introductory part of your video. Concept description, concept diagram, concept representation, concept pictures. Lots of things in the sequence. At the end, you can put your ending credit, your names, someone in charge of making this video. But actually, your design representation, design visualization, showing your design, that's the matter. That's the most important thing. Animation clip made by 3D Max or SketchUp, Rhino, that is just one part of your design representation. How about still images, architectural drawings, images? They are also one part of your content, main content, okay? Let's compare to this still image-based representation, very conventional 2D design panel. It also has title, heading, text, diagrams, concept representations, concept descriptions, rendering images, visualization, 3D, 2D, plans, elevation, very typical drawings, and so on. All they are the content of your video-based presentation, okay? That's exactly same to the one you need. We compared those two different approaches. They are eventually same. That's the topic. That's the main thing that I want to tell you. Okay, example video. Let's take a look. This is the example you experienced in the lab exercise, okay? There is slab and wall objects and a foliage. You can render this scene, okay, by simply clicking render button. How to make animation? That's one of the subjects for today's lab exercise. You can get sequential JPEG images, okay? If you put some arrange, time slide, and you can put some movement of camera or movement of object, and then you can make this kind of sequential render images. This is exactly what you need to do for today's lab exercise, for animation making. Of course, you can save this animation to AVI file or something else, but I recommend you always render this sequential JPEG. I'm going to tell you in technical aspect for this one today. Something more about technical aspects of video making, animation making. At first, video file formats. Before video file formats, let's quickly look at very, very fundamental applications or mechanisms to create video presentation. Actually, next semester, we are dealing with real video presentation manner, software, and your submission going to be video presentation. But anyway, this time, I'm gonna overview something. SketchUp, V-Ray, Mental Ray, 3D Max, Rhino, Maya, any 3D application has specific technical features to create video animation. By using them, after creating video formats, files, Photoshop, After Effects, or a lot of utilities are in charge of editing your JPEG sequence. And then you can combine them by using Power Director, Premiere, Vega. There are a lot more commercial tools or free tools, utilities for composing your video, authoring your video. Okay, this is fundamental mechanism. Let's take a look file formats. Edison's invention, after that, that's so-called analog, but nowadays we are using digital, such as MP3, MP4. Usually they was uncompressed. Uncompressed file formats are here: WAV, bitmap image, AVI, uncompressed video. They are uncompressed. But most digital files has compression, simply because it's too big file size, especially videos. But the format is very different standard. Take a look, compressed files, MP3, compressed audio file, JPEG, compressed image file, MP4, compressed video file. What is codec? You know what is codec, right? Compressor and decompressor. We need both of them, okay? Compressing file and decompressing file. That's codec, okay? C-O-D-E-C, codec. When you download a video and if you play, sometimes computer says you need to install this codec in order to play this movie. That's codec, okay? Compressor, decompressor. How about JPEG codec? JPEG codec is very open and very open to public. So any application, any Windows, any operating system, even your smartphone, Android phone, iPhone, they have JPEG decompressor. That is why you can see JPEG image. Even web browser has JPEG decompressor, okay, in terms of its mechanism. But video file format has very complicated decompressor you need. That's why you need to install. Anyway, codec plays an important role to store your video, audio, pictures, and so on. Another one, web streaming format, such as YouTube video, okay? Let's compare uncompressed WAV file, 30 megabytes, 3 minutes audio. But 3 minutes audio can be compressed in MP3 format in 3 megabytes, okay? That is why we need to use compressed file. And we need to decompressor software in order to play those compressed files, okay? That's why we need codecs. Actually, for animation video, there are thousands of things we need to take care of, but I like to put some little bit more emphasis on very critical things we have to know. Take a look, red fonts. First one, screen size, pixels. DVD has 720 pixel by 480 pixel. HD, 1280 by 720 pixels. That's HD. How about Full HD? 1920 by 1080. That's exactly what I request for your final project, okay? This is final project resolution. How about FPS? Another very important thing you need to know, frame per second. 1 second, how many frames, how many still images you need? Think about the flipbook animation. If you have 30 images in your flipbook, that's usually going to be just 1 second video, because we usually use 30 FPS for smooth video file format. At least minimum is 25, okay? Okay, let's think about render time. What if your render going to take 1 hour for one single image in full HD? That's one single image takes 1 hour. How about 30 images? Simply say 30 hours. 30 frames, 30 still images going to be 1 second, okay? In terms of 30 frames per second. That means 30 hours going to make 1 second animation. So it's really slow. That's the big difference between still image render and animation render. It's a matter of time, matter of your computer hardware performance, okay? Codec, file type is matter, but I recommend you MP4 or MOV. Why? They are very compatible to your smartphone mobile interface. Android, iOS, iPhone, Windows Phone, they don't have any problem for playing MP4 and MOV. That's why I recommend you MP4. And also it has very, very high rate compression, very well compressed file. To audio, bitrate, codec, they are also important. Authoring a video, okay, some process, but let me quickly show you a demonstration. Just screenshot of the application. This application, there are a bunch of similar utilities. This one in charge of converting video file formats from AVI to MP4, something like that, without any data loss. But you can make your scene very small size file and smartphone adaptable, compatible file formats. Wave to AVI or AVI to MP4, something like that. Camtasia is very good for screen capturing in video, not just the still image. Sometimes you need to capture your screen working video format, okay? So this one can capture your video. Whatever you do on your computer screen, this application can capture. Right now, actually, we are using some screen capture format. The file format is MP4, okay? For the class OCW, also this screen also captured by certain type of screen capture video. Another one, After Effects. After Effects is Adobe software. Simply say this is video version of Photoshop, okay? Photoshop in charge of editing still image, but After Effects in charge of editing sequence of images. In other words, editing video. Same company, Adobe, okay? But this is video version of Photoshop. That's the point. Premiere, very professional movie making application. Flash, YouTube video, they are all flash based. This is very compatible to web streaming, internet based video. But actually this one, Power Director, very intuitive and easy to use application. This is timeline, okay? 0 second to 30 second. You can place your own video, your own background text, your own image, your voice, whatever it is, you can place in this timeline, okay? Anyway, editing video can be summarized in this single slide. Firstly, components, library. Your animation clip made by 3D Max, made by V-Ray, or you're taking video. You can take your friend's video for the resource of your video making, okay? Your background music, your audio, your voice, still image, render image, your pictures, whatever it is, it can be one part of your components, okay? Timeline, 0 second to the end of your video. On this timeline, you can place your component, okay? Your text, your animation, your video, whatever it is. Actual timeline is the main body of your video editing and previewing. The final is exporting your video in using codec. So MP4 file, MP3 file you can create. This is very, very, very simplified mechanism how to create video. So some more descriptions. But let me finish the lecture today. But at the end of the lecture, I like to put more attention, put more emphasis on the content. Even if you are just walking through the technical aspect of video making, but content is matter. I told you before, our class, design computing, eventually design, not computing. So video, eventually content. Content is matter, okay? So this is storyboard. What if you are a director of your video, your movie, your commercial video, whatever it is? You need a plan, okay? Do you remember what's the most important thing at the beginning of your 3D Max design? Defining UOD, okay? Universe of discourse is the most critical thing. This is the same. You need a plan, and then you can make your video. That's my point, okay? So we're gonna move to the lab exercise, okay? After copying the file.